Here's integrated 3, problem 5-13. It says, graph these inequalities. What is the area of the enclosed region? So a lot of times when it says graph the inequalities, you guys are graphing them on Desmos, which is okay, but in this case, I don't think Desmos is going to help you at all. So if you remember our parent function, the parent function was y equals absolute value of x, and it was just, it looks like a little V shape, and looks kind of like that, and the slopes of each of these sides are 1, like it goes up 1 over 1, up 1 over 1, up 1 over 1, okay? So we know that we can do transformations on our parent functions. So this is just that V-shaped absolute value function, but it is translated to the right by 2. So all I have to do is just count to 2, and then my slope is going to go this way. And same thing, it's going to go this way. And I'll just use a, you don't have to make all those dots, you can just use a ruler. And we know when it's an inequality, we're supposed to shade the regions where that make it true. So this says y is greater than the absolute value of x minus 2, so it's going to be above the graph. You could plug in 0, 0 just to make sure it's not below the graph. Like if I plug in 0, let's do that in pencil. Like I'm saying, I think the shading is going to be above the graph, but let's plug in 0, 0 just to check. So is 0 greater than or equal to the absolute value of negative 2? Well, the absolute value of negative 2 is 2. 0 is not greater than or equal to that, so it's not going to get shaded below. It's going to get shaded above, just like I thought. So we'll just do some scribbling shading in here, and then we're ready to graph the other absolute value function. So this one is going to be flipped upside down because of the negative sign in front of the absolute value. So it's a reflection across the x-axis, and this 4 is going to lift it up by 4. So what I'll do is I'll go up by 4, 1, 2, 3, 4, and remember it's going to reflect, so it's going to be facing down. I put some of those dots in there just to help me with my ruler to actually line it up so it's actually straight. Okay, and so we get this, well, we need to figure out the shading first. Y is less than, so I predict it's going to be below the graph, but we can always plug in a point. 0, 0 is a nice and handy point. I think 0, 0 would make this true, so we'll check and make sure. Is the absolute value of 0 actually less than 4? Yes. So maybe I'll shade it this way. And where the shading, where it overlaps, is in this box right here. So it'll be more darkly shaded inside this box. So what they're asking us is, what is the area? What is the area of the enclosed region? So now that I did all that hard work of shading it, I kind of wish I didn't, because now you can't see the grid lines. So what I'm going to do is just erase what I shaded so that we can count the boxes. That's the best way. There's other ways of finding the area here, but I don't really want to find the equations of the lines and the perpendicular lines and use the distance formula. I can just use these boxes. So see, like this box right here, that's a whole unit. And here's another whole unit. So that's 2 whole units. And then I see some half boxes, if that makes sense. These 2 triangles, each of these triangles is a half of a square or whatever. So if I shade these 2, well, that's another square. So how many squares do I have so far? 1, 2, 3. Shade these, that'll give me 4. Shade these, that'll give me 5. 5. And then these 2 triangles, if I add those together, that gives me a total of 6. So you say the area equals 6 units. I hope some of you were resourceful enough to do it this way.